In a control room in Pasadena, engineers waited for a single signal. Confirmation that the spacecraft had slipped into orbit around Mars. It never came. After 9 months of flight, the Mars Climate Orbiter burned up in the Martian atmosphere, and the mission it belonged to had cost $327 million. And when NASA's board found the cause, it did something strange. It refused to look for someone to blame. Not a broken part, not a meteorite, not one engineer who slipped, but a discrepancy that a single check would have caught. It just wasn't caught in time. The Mars Climate Orbiter was part of NASA's Mars Surveyor 98 program. It was meant to be the first real weather station at another planet, and a relay for the lander flying close behind it. Lockheed Martin built the spacecraft in Denver. The Jet Propulsion Laboratory, JPL, in California, flew it. 2 teams, 1 spacecraft, and a seam between them that no one truly owned. On December 11, 1998, a Delta II rocket carried it off Cape Canaveral. Ahead lay 9 months and more than 600 million kilometers of empty space. Everything aboard was working. The problem wasn't aboard. It was already waiting back on Earth. To hold its course, the navigators constantly accounted for the tiny nudges of the spacecraft's thrusters. The software written at Lockheed reported the force of those nudges in English units, pound force. JPL's navigation software expected metric, newtons. The same push came out different by a factor of 4.5. On any single step, the error was almost invisible, but it built up, day after day, week after week, for all 9 months. And the navigators could see the craft drifting slightly off. They noticed it again and again, grew uneasy, nudged the course back, raised the alarm. But the real reason, that the data was arriving in the wrong units, the process never uncovered in time. One file was already doing the math wrong. We'll come back to it. In the last days before orbit, the navigators kept recomputing how high the spacecraft would pass over Mars, and with every pass, the number fell. The plan had called for 226 kilometers. A day before the maneuver, the math gave 150 to 170. About an hour before the engine was due to fire, just 110. The margin was melting in front of them, but the team hoped the craft could survive even that low. On September 23, 1999, the spacecraft turned, lit its main engine, and began braking at Mars. Minutes later, it passed behind the planet, exactly as planned. At 4 minutes past 9 Greenwich time, the signal cut out. It was supposed to return from the far side. It never did. Later, engineers reconstructed the real path. The spacecraft had passed just 57 kilometers above the surface. The line below which it could still survive was around 80. 57 was far too deep. The Mars Climate Orbiter either burned up or skipped off the atmosphere and was thrown into orbit around the Sun. That slow buildup in the units was the cause. A whole interplanetary spacecraft, undone not by an accident and not by space, but by a mismatch of measures that one check of the units would have caught. On November 10th, NASA's investigation board explained why there was no one to blame. The fault was in the process, not in a person. Thrust was computed in pounds instead of newtons, inside the small forces software, and the data passing between the 2 teams was never fully cross-checked. But underneath that sat a deeper question. Why did the process let the error live all the way to Mars? The answer was in 3 words the agency lived by then: faster, better, cheaper. Through the 90s, NASA was pushed to reach the planets more often and for far less money, and the Mars Climate Orbiter was part of that new philosophy. But cheaper also meant fewer people. One navigation team was flying 3 missions at once. They were overloaded, and no one was checking their math from the outside. When an independent board took apart the entire Mars program, the verdict was blunt. The checks and the testing that should have caught the error were inadequate. This was never really about one swapped unit. The system was too thin to catch any error like it. The units just surfaced first, and the program proved it. 3 months after the orbiter, a second spacecraft from the same program died at Mars, the Mars Polar Lander. Most likely, its engines cut off too early, and instead of a soft landing, it slammed into the surface. 2 losses in a row, 1 program, 1 shared route, too few hands to catch the mistake in time. After that, NASA rebuilt the program. It brought back independent checks and eased off the race. The spacecraft wasn't killed by anyone's stupidity. It was killed by the seam, the place where 2 teams handed the work to each other, and each was certain it had done its own part right. The full breakdown, the numbers, and the sources are in the description and our Telegram.